Hello, friends. I hope you guys are having a great week. We are moving on to Unit 8 today. So today we are going to cover Unit 8, Lesson 1, and this is going to be called Characteristics of Quadratic Functions. So you're just going to add this to the table of contents you already have going, okay? So this unit, we are going to do domain and range again, which we've already done several times this year. We're going to write quadratic equations. We are going to write quadratic equations from a point, a vertex, and a point, a graph. We're going to write it in this form, and we're going to rewrite equations to standard form. We are going to write equations of quadratics given the vertex and other points. So again, write equations. That looks like it's the same thing. That says the same thing, doesn't it? Yep. Oh well, I don't know. We got it. It's on there wrong. It's repeated. We're going to graph quadratics. We're going to talk about how the graphs move and how they transform and how they can be changed based on what the equation looks like. We're going to talk about all of the characteristics of the graph of quadratics, which is what we're going to do today. And that includes the x-intercept, which we know that word, the y-intercept, we know that word, the zeros, which we know from the other day is the same thing as x-intercept, maximum value, minimum value, vertex, and the axis of symmetry. Okay, so these are all characteristics. We're going to talk about those today. We're going to talk about relationships between the factors and the zeros, which we've already really touched on. We solved a factor, and then we found that those factors are our solutions, and that's all that this one right here means. We have this is the effects of the graph, talked about that, and writing equations using technology, which we will do on Friday. So for this unit, we're talking all about quadratics. We're going to have this lesson today, and then there's a Desmos activity that you need to do. Then tomorrow, you're going to start a project. This project is going to take you several days to complete, but you need to be working on it every day. If you get behind, you will stay behind. So make sure you're working on it every day. This project is going to be a test grade, and I'll talk more about it tomorrow. But you need to make sure you're working on the project every single day, get it done and turn it in, because that's going to be your test grade for this unit, okay? So here we go, Unit 8, Lesson 1, Characteristics of Quadratic Functions. So if you were in class, I would have you look up these words and put them on the graph where they belong. But since you're not, I'm going to go ahead and give these to you. So when we have quadratics, and that means we're talking about things that look like ax squared plus bx plus c. So we always have this x squared term when it comes to quadratics. When we graph quadratics, we have this U-shaped graph. So our graphs are going to have this U-shaped. If they're upside down, they're going to kind of look like an N, I guess. But we have this U shape, and this is called a parabola. Then we have these points where we cross the x-axis, which from the past few days, we know that these are the x-intercepts. We have a point where we cross the y-axis, and that's the y-intercept. So we've done parabola, we've done x-intercept, y-intercept. From the past few days, we know that zeros and roots are the same thing as x-intercepts. So we got that done. The newest things that we have are the vertex and the axis of symmetry. So our vertex is this point right here. It's going to be the lowest or the highest point on our graph. This is called the vertex. And because it's the lowest or the highest point on the graph, that's where we get these two terms. So maximum means highest. Minimum means lowest. So because this graph opens down, the the lowest it goes is going to be called the minimum. So here the vertex is the minimum. There we go. If it was, if the graph opened like this, then the vertex would be a maximum. Right? And then last but not least, we have what is called the axis of symmetry. So this is this imaginary line that goes through the middle of our graph that cuts it in half perfectly. So what that means is my graph on both sides is symmetrical. So just like, if you cut a heart in half, a heart should be perfectly symmetrical on both sides, right? So this axis of symmetry is going to cut my parabola in half, and it means that things are symmetrical. They look exactly the same on the other side. So it's like I put a mirror there at the axis of symmetry and redrew my line on the other side. So down here we have some definitions. The vertex is a maximum when it's the highest point on the graph. The vertex is a minimum when it's the lowest point on the graph. And solutions are called roots or zeros. And solutions are also called x-intercepts. So that's just kind of a review. These two are a review from the past few days. Solutions, roots, zeros, x-intercepts, these are all synonyms. They all mean the same thing. Those are the points where we cross the x-axis, which you're looking for. So if you're asked for any of those things, the roots, the zeros, the x-intercepts, the solutions, where did it cross the x-axis? Okay, so to find the equation for the axis of symmetry, we can use the formula x equals negative b over 2a. And x is going to be, and this is going to be the x value of the vertex. Sorry. So if at my vertex, I have a point and it's going to be x, y. The axis of symmetry is going to always be whatever my x value is. It's going to be x equals then the x value of my vertex. So if I came to graph it in Desmos, then I can click on my vertex. My equation for the axis of symmetry is going to be x equals whatever that x number is. Okay. I'm going to show you how to do this over the next few days in this project. Okay. So to find the vertex, we're going to substitute the axis of symmetry value into the equation and solve for y. So if a is bigger than 0, if our a value, so when we have ax squared plus bx plus c, if this number is bigger than 0, then that means we have a minimum. That means my graph is going to open up. It's going to open like this. If a is less than, or the same thing. If a is less than 0, if it's a negative number, then that means we have a maximum. And that means my graph is going to open like this. It's going to open down. Okay, so if a is positive, the number in front of x squared is a positive number, my graph's going to open up. If it's a negative number, my graph's going to open down. Okay, so to find the y-intercept, substitute 0 for x and then solve for y. So if we want to find where it's going to cross the y-axis, that means my x value is going to be 0. So I'm going to plug in zeros wherever I have an x and then solve for y. So to find the equation for axis symmetry, so on these three, we're going to find the equation for the axis symmetry. We're going to find the vertex, the y-intercept, and we're going to say whether the vertex is maximum or minimum. Okay, so we're going to do this. I'm going to show you how to use these formulas, and then I'm going to show you how to use Desmos to do it. Okay. So on number 1, we can identify a equals 1, b equals -2, and c equals -3. So since my a value is bigger than 0, that means we're going to have a minimum. So that's the first thing I identified. Then we can figure out our axis of symmetry by using the equation x equals -b over 2a. So that means I'm going to do x equals -2 over 2 times 1, which means I have 2 divided by 2, which is 1. So my axis of symmetry is going to be x equals 1. Then we can figure out our vertex. We know our x value is going to be 1 because that's what we set up here, right? Our axis of symmetry is that x, that's going to be the x value of our vertex. And then I can plug that into my equation for x to figure out what y is. So I can do y equals 1 squared. Wherever there's an x, I'm going to plug in 1. Minus 2 times 1 minus 3. So that's going to give me 1. 1 squared is 1. Negative 2 times 1 is negative 2 minus 3. So I have 1 minus 2 is negative 1. Minus 3 is negative 4. So that means my vertex is going to be at 1, negative 4. Last thing we want to do is find the y-intercept. Let's see, we found the axis of symmetry, vertex, y-intercept. We've said it's a minimum. So we want to find the y-intercept by plugging 0 in for x. So that means I'm going to do y-intercept. That means I'm going to have 0 and some number for my y value. So y equals 0 squared. I'm plugging this into the original equation. So 0, anywhere there's an x, I'm going to plug in a 0. 0 squared minus 2 times 0 minus 3. So I have y equals 0 minus 3. So y equals negative 3. Okay? So we can do all these formulas, or we can use Desmos. Let me show you how to use Desmos. Let me move myself out of the way. Oh no, I don't have Desmos open. So in your Canvas, you should open Desmos here. Open a new tab. Oh, I've got it over. It's on my other screen. Forgot. So the second equation, I'm going to type it into Desmos. Y equals negative x squared minus 4x plus 5. And zoom out a little bit. So I want to identify, this is my graph. Let me move this thing over here. I want to identify my axis of symmetry, my vertex, my y-intercept, and I want to say, is it a maximum or minimum? Well, looking at the graph, it's opening down, so I don't have a lowest point, I have a highest point. So that means we're going to have a maximum. So my vertex, excuse me. Let me make this go away so we can see the graph. I can put these things side by side. All right, my vertex is that very highest or lowest point, which is right here. And in Desmos, you can just click on it, it gives you the answer. So my vertex is at negative 2, 9. And my axis of symmetry is x equals whatever this x value is. So x equals negative 2. My y-intercept is where across the y-axis. So that's at 0, 5. Isn't that so much easier than solving? Desmos is so great. So let me go ahead and go over the next one too. So this last equation, we have y equals 2x. Remember, you can do shift 6 to do squared. 2x squared plus 36x plus 170. You need to use Desmos for this project. Do not try to get away with doing this project without Desmos. You're not going to be able to do it. You can't use PhotoMath to do this project, okay? You need to do the whole project. You need to use Desmos. All right, so I can zoom out on this graph. My vertex here is going to be a minimum. So I have minimum. I spelled it wrong. Okay. The vertex is at negative 9, 8, which means my axis of symmetry is at x equals negative 9. And my y-intercept is where we cross the y-axis. I'm going to move the graph up until I see that point. There's going to be a gray dot there, and that's at 0, 170. That's it. Okay, so now there is an activity in Canvas. So go to modules. Come on. There we go. Go to modules, and you're going to do will it hit the hoop? And click here. Log in with your Google account. Put your name in there. I can see on my end. You don't have to submit anything. I can see on my end that you've logged in, okay? So make sure you use your name so you can get credit. And you're going to just work through. So you need to read the directions and do what it says. It says drag the black points to create a line that models the blue points. So I'm going to take my black points. I'm going to drag them like this. I'm going to drag them to match, to try to touch all those blue points. Then I can hit next. Okay, so then you're going to answer these questions. You're not going to know all of the answers to all of these questions because we haven't talked about all of the things that deal with quadratics, but do the best you can. Think about the question and answer them. Okay, so it says lines used to be the only kind of mathematical relationship we needed. Lots of models are linear. So far this year, all we've talked about is straight lines. That's all only graphs we've looked at. Now we're going to start talking about these parabolas, so these U-shaped graphs. But lines are the wrong model here. What does your line say will happen to the basketball? So we have this little guy here, and he's shooting a basketball, right? But if we said this line represents what's going to happen to the ball, then what's going to happen? What does it say? That he's going to throw it, and it's going to keep going forever and ever and ever. But is that really what happens? So explain that. Explain to me what's happening. Then you're going to start, like this talks to you about parabolas. Then you're going to start watching and guessing, is it going to go in? Is he going to make the basket or not? So this is kind of an activity. It's going to stop here. You're going to try to have to figure out, is it going to hit the basketball hoop or is it going to hit the backboard? It's going to go all the way completely over the goal. So tell me, is it going to go in or out? You'll have several different shots. Then you'll see more videos where it actually goes through and you'll just decide, did it actually hit the hoop or not? Okay. So make sure you do this. You don't have to hit submit. You don't have to do anything in Canvas. Go through the whole activity because I can see what slide you're on. I can see your name. I can see all the work you've done. So go through this whole activity, and that's it for today. So tomorrow I will explain to you how to do the project. So if you have any questions, please let me know. See you later.